Dear students, in today's class we are going to see a typical example on projection of straight lines. This is the example we are going to take. A line AB 70 mm long has its end A 35 mm above HP and 30 mm in front of VP. The top view and front view has a length of 45 mm and 60 mm respectively. Draw its projections. So this is the example we are going to take. So here the length of the line, that is the true length of the line, is given as 70 mm and end A is 35 mm above HP and the same point A is 30 mm in front of VP. Then they have given the top view and front view length, that is the top view is 45 mm and the front view is 60 mm. So with this data we have to draw the projection of this particular straight line. So let us start the problem. So first, as usual, draw XY reference line. Then mark the point A, that is 35 mm above HP. So let us mark that point. Take the scale. So let us mark 35 mm point from the XY line. So 20, 30, 35, it is somewhere here. So we have marked a point A dash, that is a point above HP. So draw a line from there. This can be marked as A dash. Similarly, the same point A is 30 mm in front of VP. So since it is in front of VP, it should come below XY line. So keeping the scale on the same straight line, so I have marked 30 mm below XY, that is in front of VP, the same point A. So mark 30 mm point. Then draw a straight line from there up to that 30 mm point. It should be a straight line. Let us mark this as A. Then that's all. We have created the point that is 35 mm above HP and 30 mm in front of VP. Let us draw the locus line at this particular point. So this will be the locus of A dash. Similarly, draw a line crossing A, that will be the locus of A. Then let us name the locus line. Let this be locus of A dash and this be locus of A. Similarly, let us mark the dimension, that is 35 mm above HP and 30 mm in front of VP. So I am using the different color for your understanding. You can use the same pencil. So I have marked the arrowhead. So it should be the 3:1 ratio. So draw the arrowhead in such a way that it should be 3:1 ratio. So we can name this as 35 and this as 30. Then the true length of the line is given as 70 mm, but the HP inclination, that is theta value, is not given. So you can't draw this particular true length line. Instead of that, the top view and front view has a length of 45 mm and 60 mm, which means the top view is given as 45 mm. So we know that, so the length of the top view will cut at locus of A. So let us do that one. So take the scale. So the top view will come below XY line. So the length is 45 mm. So take the scale and keep on locus of A and mark 45 mm. So 40, 45. Let us mark one point. Okay, so let us name this point as B1. So I will tell at last why this is named as B1. Okay, similarly the front view length is given as 60 mm, so that should cut at locus of A dash. So take the scale and at locus of A dash mark 60 mm. So 60 will be here, so mark the point. So this can be named as B2 dash. Okay, we know that there will be a vertical line from B1 towards upward and B2 dash towards downward. So let us draw that line. So from B2 dash, draw one vertical line to some extent. Similarly, from B1, draw one vertical line towards upward to some extent. So let us not conclude the length of these two lines, because we have to mark the point of the true length on this particular line. So that's what we are going to do. So take the compass, measure the true length of the line, that is 70 mm, and with A dash as center we can draw one arc on the extension of B1 line. Similarly, of same length with A as center we can draw one arc here from the extension line from the point of B2 dash. So this point can fix the true length. From there we can find the true inclination towards HP and VP. That's what I am going to do. Just listen carefully. Take a compass. So measure the true length of the line. So it is 70. So 70. Take the compass with A dash as center and of same length, that is marked. Draw an arc to cut at the extension line from point B1. Don't draw this much length of arc, small arc is enough. So since I am using a software, I couldn't able to rotate the compass as such a way. So I am going to erase that extra line. So while using a manual compass, it is enough to cut the arc at this extension of B1 line in such a way that it can be a small arc. Okay, so this point can be called as B1 dash. So why I am mentioning this as B1 dash means we have mentioned B1 here, since the extension can be marked as B1 dash. So I have marked B1 dash. So it is not compulsory that it should be B1 and it should be B1 dash. You can mark whatever name you want, but you must be very careful that the name should not get repeated anywhere. You should use a different names. Then we can draw a locus line towards this B1 dash point. So I am drawing a locus line towards the B1 point, that is B1 dash point. So it should be locus of B dash. So let us mark this as locus of B dash, since B dash point will cut over this line. So I am giving the name in such a way that it is locus of B dash. So then join this A dash and B1 dash point to form the true length line. Okay, it is the true length line. So you can measure the inclination using protractor to calculate the theta value, that is HP inclination value. So let us do at last. Then we will draw the true length line which is inclined to VP. So which is inclined only to VP. So I am going to draw that line. So the same true length, that is 70 mm, should be marked on compass. So take the compass, measure 70. So same 70 I am marking. Release the compass with A as center. We need to draw an arc to cut this point. Okay, so I am keeping again the scale so as to measure the correct length. So it is exactly 70. So now I am going to draw one arc to cut this extension line that is drawn from B2 dash. So let us erase the extra lines. So this point will be B2. Since it is drawn from extension of B2 dash, I am marking this as B2. Then draw the locus line crossing B2 point, so that can be called as locus of B. So draw one line crossing B2 point, that is the locus line. This will be the locus of B. Okay, that's all. We have drawn all the locus line, and then join A and B2 to form true length line that is inclined only to VP. Okay, so you can take the protractor to measure theta and pi value. So when you keep the protractor here, so it is showing exactly somewhat 50. So it is showing as 50 degrees. So theta value is 50. Similarly, rotate the compass and keep here. So when you see here, so the angle is approximately 30. So you can get 30, 31 or 29 like that. So it will be plus or minus 1. I am not using a perfect measurement to draw these lines. That's why I am getting as 30. So if you get 31 or 29, it is well and good. You can fix that particular angle. So I am getting theta as 50 and pi as 30. So you can mention here itself. Otherwise, you can write the answers on the right side of your paper. So that I will do. I am writing here as answers. You can either use HP angle, VP angle, or just you can use the symbol that is theta and pi. Okay, so now let us continue the problem. We have to draw the front view and top view. So the problem is quite simple. We have already finished. So take the compass with the A dash as center and A dash B2 dash as radius. Draw one arc to cut locus of B dash at B dash. So this A dash B dash will be the front view. So I am going to draw that. So take the pencil. So it is the front view. So let us use HB pencil. Join A dash and B dash. So this will be B dash. Okay. Similarly, take the compass with A as center and A B1 as radius. Draw one arc to cut locus of B at B. So this point will be B. You have to use 2H pencil to draw this. Okay, I have used the 2H pencil. Then join A and B to get top view. So this will be B. Join A, B using HB pencil. So this A, B is top view and the A dash, B dash is front view. That's all. The problem is almost over. Then some of the missed dimension should be marked. That is the true length in front view and true length in top view. So some of the missed dimension should be marked. That is the true length of the line. So it is 70. You can mark A dash and B1 dash as 70 using some extension line. So I am using extension line. You should not cross this question. Since I am having no space, I am drawing like that. So you can draw this as closed arrowhead. So this will be 70. Similarly, this way you can mark this as 70. So you should mark on either way. While drawing this extension line, you must be very careful that it should be a perpendicular line towards that respective line. See here, the extension line that I am drawing here is perpendicular to A dash and B1 dash. Similarly, the extension line should be perpendicular to A and B2. So this can be measured as 70. This also draw in closed arrowhead. So this is 70. So that's all. We have drawn the required lines. Clear? So if you want, you can mention the theta value, that is 50 degree here and 30 degree here. Okay. So after finishing the drawing, you can check whether your answer is correct or not by drawing the end projector. End projector is nothing but the line that is drawn from B dash to B. So I am using a different color for your understanding. So if you draw a line from here, it will be a perfect straight line. So it will be a perfect straight line that is exactly parallel to A dash line. Okay. So then your answer is correct. That's all. So you can write here as all dimensions are in mm. Then one more dimension I have missed, that you can draw that also. So that is front view and top view length. So we have taken the front view length, that is 60. So that can be marked here. So it should be 60. Similarly, the top view length is taken as 45. That can be marked here. That is A and B1. This will be 45. Also, the direction of the rotation can be mentioned in the arrowhead. That is, we have drawn the arc from A dash, taking a distance of A dash B2 dash. We have drawn one arc in this direction, that is in anti-clockwise direction. So you can mention that also in arrowhead. So like this you can mention it should be a closed arrowhead. Okay, so all the arrowhead should be closed. I just drawn an open arrowhead. So in that particular software it is very difficult to draw closed arrowhead. So that's why I am drawing like this. But you should draw the closed arrowhead. Similarly here, this rotation will be on clockwise direction. So you can mark the arrowhead like this. Okay, so that's all. So in next class we will see a different example on projection of straight lines. Thank you.